Hi everyone, so today we are going to learn some basic NetLogo skills, and we are going to start with some quick review, basic syntax, sample model. This model is something that I found online. It was created by Martin Hilbert from UC Davis Computational Social Science. Then after, I'm going to show you how I did the code, and after that we're going to have an activity. But first, let's do a quick review. I hope you still remember our tutorial with Erica from a few weeks ago, where she described the different components of the NetLogo model. You have your turtles, which are your agents. You have your patches, which comprise of your environment, and these are represented by x and y coordinates. So if you can just imagine an x and y axis with 0, 0 being at the center, then that is your environment. But in the case of this model, I just made it all black to lessen the complication. And then you also have other components such as buttons, sliders, plot, input, monitor, etc. So when it comes to the syntax, there are also several components. You have your commands and reporters. These are procedures that you define, such as to, or ask, or tick, or set. And these are all defined in the NetLogo dictionary. You can just open this on your web browser and you have so many commands that you can choose from. But it really depends on the NetLogo model that you're trying to create. The next component are the functions. These are commands defined by you, the observer. One example on the left is the coin flip function. There isn't really a coin flip function on the NetLogo dictionary. This is something that you create and you define within your code. I just listed down some of the commands and reporters that I used for the NetLogo adoption model that I created. Okay, so let's look at the model. As you can see, this is how it's supposed to look like in the end. If you push the go button, you'll see that the turtles are going in different directions and they turn from blue to orange. In the code, I have dictated that one of the agents should be orange. The orange agent is an early adopter, and every time that the orange agent interacts with the blue agent in the same patch, the blue agent turns to orange. Alright, so for this part of the tutorial, I'd like you to open NetLogo on your computers. Let's set up the environment first. I'm just gonna put a note here just to describe what this is supposed to do. Clear all just clears all the data, and then reset text, super straightforward, just resets the text, and then you create the turtles. In this case, I'd like to create 50 turtles. Or 50 teachers in our case. And I want the turtles to be shaped like a person. And you will see that here. Turtle Shapes Editor, you will see that you have a person here, right? And then let us set the size to 3, and then let's set the color blue. Alright, there you have it. And then let us end that. Let us try to see. So as you've seen, I've already set that up. So let's do it again so that you know how that happened. So this is the setup button. There you have it. And then, right, so when you set it up, you'll see that it's just in the center. These are actually 50 teachers lying on top of each other. So you want them to be at random places, right? Let us set it randomly. So you'll use the command set xy, random x core, and random dash y core. Yep. Right. Let's see. Let's check first. That makes sense. let's set it up. So now they're all in random places. Alright, so let's move on and define what the to-go button will do. And with this button, you want the turtles to move randomly at different directions in a non-deterministic way. And how you will do that is to use the command if-else. And we are going to come up with a function called coin flip. Later on, I will show you how you will define that, but let's just keep that. And then you have different conditions. If the coin flips true, then it will go right randomly at 40 degrees, or it will go left randomly at 40 degrees. And then it will go forward randomly 4 steps. So that means that it will go 4 steps between 0 and 3. So move randomly between 0 and 3 steps forward. So this just means, I'm just going to define this so that we don't forget what it means. If the coin flip is true, 0, just hold on to that thought and I'm going to explain what that means. Then turn right up to 40 degrees. Otherwise, turn left at 40 degrees. Move forward. And then let's close this. Let's close with a tick. That's just adding 1 unit of time. Add 1 unit of time to the counter. And then let's end it. Okay. Now, if you check this, it will say nothing named coin flip has been defined. So how will you define this? You're going to use the command to-report. Okay. Let us put there a random word, and then it just means that the system will come up with random commands in pairs, which is 2, with either it's true or false. And since everything starts at 0, true will be 0 and false will be 1. So going back to this explanation on top, I said if the coin flip is true, meaning 0, then it will turn right up to 40 degrees. So this will be 0, and otherwise then it will turn back at 40 degrees. So that's just that. It's just defining what coin flip means. So let's check for at the end. Let's check again. There you go. Doesn't come up with an error anymore. Then let's try that. Let's add the button go. Go once. Let's say go once. Let's just move this just to make it look nicer. And then see? They just go about randomly. Alright, so now our basic model is working. You have all the teachers there, and they're all blue, and they're just walking around randomly. Now, what we have to do is to introduce the early adopters. How we do that? So let's use the command turtle spawn, and let's come up with a function early adopter, something that we define ourselves. This is not in the NetLogo dictionary. This is something that you create yourself. So we created this, and I added a question mark just to remind me that this is either true or false. So what does that mean? When you set up the environment, you can set the early adopter function as false, meaning all of the 50 teachers will be non-early adopters. But then you want at least one of them to be an early adopter so that they can influence others, right? So you ask one of the turtles to be an early adopter. True. There. So as you can see, is the turtle an early adopter? False or true? That's just what it means. And then let's go back. Let's check it first. Checks out. And then let's go back. Let's set it up. Right, but we don't really know who among these teachers is the early adopter. So let's add a caller to the teacher who is an early adopter. So let's say if early adopter is true, then set color orange. Let's say make all, no, that's supposed to be a semicolon. Make all adopters orange. In this case, it's just one, right? Let's check. Oops. It came up with an error. So let's move this to the Go section. There. Let's check it again. Okay. So what happened was that I put it in the setup section, which doesn't really work because then I can't do that as an observer. So I then moved it to Go. Okay. So let's set it up, and then let's go once. You see, you have this early adopter walking around, but it's not really doing anything, it's just walking around, right? Then how do you make this early adopter influence others? Let's type this command: if any other turtles here with early -adopter. Basically, in human language, this means if another teacher is at the same patch or location, it will do this. It will set early adopter true. Yep. This means that early adopter will influence another teacher. What this part means is that whenever a non-adopter meets an early adopter in a patch, then it will become an early adopter, which is going to be true. And let's check this. Oops, it has to have a question mark. Another one. Okay, that clears out. So this is very strict. Really have to be consistent with your syntax. Okay, let's look at the interface. Let's set this up. Let's see if it works. Let's go once. There you go. It just takes a while. So as you can see, the problem with that was that it's too slow because you're just going once. Let's add a button called Go Forever. Go Forever. And then let's click this. Let's try to do that. Go Forever. So you see, it's starting to spread. They're turning into orange. So that just means that the model is working. And we're done with that. What I want to do next is to add a plot. But that is something that I want you to do in the activities section of this tutorial. So on the Canvas page, you will see different resources. I uploaded the code of this model, and then I also uploaded the NetLogo file. And the only task that you need to do is to add a plot that will show the S-curve, similar to the finished model. And that's it. If you figured it out easily, then just spend the rest of the time experimenting with the code. Maybe change the colors or change the direction in which they're moving, or whatever you prefer. And then think about ways in which we can apply it to our group work. And that's it.